So to do this, let's start off by creating a fake floor. I'm going to create a 3D object and I'm going to create a cube. I'm going to change the X to 10, the Y to 0.01 and the Z to 10 as well. So we've got a large floor here. I'm going to just shift up my camera so it's above the floor so we can see it. I'm going to bring it back a little bit to around there. So we've got a floor here. I'm also going to just name it to test AR floor. What I'm also going to do is I'm going to go to our prefabs here, and I want to look at the existing material that we have. Actually, so if I just go straight to materials, we can see that the plain material is the one that we see on the floor when we run the app. So I'm going to put that on this floor, and it's just a visual thing for us. No, it doesn't do anything else. It's just so I can see, oh, okay, this is the floor. It's got that same color floor as the floor when we're actually running the game itself. So we've got that floor there, and I'm also going to change the layer to this. So to do that, we make sure we've got our test AR floor selected. We go to layer, default, hit add layer, and then we add in the name of that layer. So I'm going to call this AR test plane. So now we've got that layer there. We've created a layer. We just have to add it now back to our layer here by going AR test plane. So now this is on its own layer, and that means that we can reference everything, reference that separately to everything else. It's similar to the way that we reference the track plane differently to everything else with a raycast. Now we can look for that. All right, so we've got this code here that runs on the trackable type, but this doesn't run in the editor. So what we want to do is do a separate line of code, separate code that runs just for the editor. So the first thing I'm going to do is differentiate between when we're in the editor and when we're on our device. So I'm going to do if application.isEditor, then we want to run the editor raycast, which is looking for the fake floor. Otherwise, we want to run when we're on the device, we want to run our regular code, right? Which makes sense. Oops, did I copy that correctly? I don't think I did. Let me try that again and paste that in there. So it's going to be pretty much identical, but we just want to make sure we do a different type of raycast because the AR raycast won't work on here. So this one, we're going to do a screen point to ray. Here we use the raycast was created using the AR core session origin, but we're not going to do that. We have to create our own one, right? So to do that, we're going to do it's similar to the other one, except we're going to use the camera.main.pixel width times 0.5. So this is doing the exact same thing. It's just that the syntax is slightly different. It's different because it's just a different set of code really, but it's doing the exact same thing, except it's not looking for tracked fields. It's going to be looking for something else, right? And we'll sort that out in a second. So we've got the ray here. Let me just make sure I've done everything right. That looks okay. So we've got a raycast. It's going out of the center of the screen, which is perfect. So half of the width, half of the height, as same as before. And this time I'm going to collect all those hit points. Everything it hits is going to go in here. And this is going to be a physics-based raycast. And we're going to send this ray out, and everything it hits is going to go into the hit raycast hit. We want a length of 500 for now. And the difference here is we only want to hit objects that have a layer mask. Oops, let me just change that to a lowercase layer mask. Now this is something we have to set now. So what I'm going to do is I'm going to go up here and I'm going to do public layer mask. And what that's going to do is that's going to say do the raycast, and if you hit this layer mask, then do something, right? And what I want it to do is actually the same thing as this code here. I'm gonna just copy this, but no, I won't do that for now. What I'll do for now is I'll just do a debug.log, and I'll do hit. Let's just test this first before we get too far ahead of ourselves. To hit the floor, and this should be hitting. So this should occur only when it hits the test floor, our fake floor. So we don't have to keep building to the device, which is really, really time consuming, right? So it's looking for that raycast is looking for a layer mask. So let's make sure we set that correct layer mask to AR test plane. And now we can test this in our Unity editor and see if we get a debug statement, right? So if I clear this for now, and if I point this camera down, do we get, there we go, hit the floor, right? So that means that it's picking up when we hit the floor, which is perfect. That's a really good start. And now we need to just add in that additional code as well and make sure it does the same as it does when it's on the device. So let's go back to our code and let's take some of this code here that we've got and let's place it in here and replace the debug statement. So we don't have the hit pose, instead we've got hit. So let's just change that to this, like so. Pretty simple. And everything else should be correct, except it shouldn't be position. My mistake, it should be hit.point. So just a difference in code there, right? And now let's see if we can get the cube moving, right? Now this isn't perfect, but we'll talk about that in a second. So our cube's there we go. We've got our cube moving on our device, and we can move the camera around as well, and it moves with the center of the camera. Now the problem with this code, and this is the only thing I don't like about it, is that we're repeating the code, one for our augmented reality device and one for our editor. And that means if we change our editor and we run our code, what we might end up having is having our old code still in the in this section of our code, and this is going to be really annoying. We'll have to change it once here, change it again here, and I don't want to do that, right? We want to reduce that. So what I'm going to do instead is I'm going to create a new function called public void game code, right? And this is going to take a vector3 called hit point. So the reason I chose a vector3 is because hit.point is a vector3 and hitPoise.position is also a vector3, right? So what I'm going to do in this code is I'm going to take our actual code here that we're usually using, and I'm going to place it inside of here, and I'm going to set this to, instead of it being to hit.point or hitPose.position, I'm going to set it to hit point. And now what that means is we've got one set of code that we can use for our normal code or our augmented reality code by just calling our game code and then putting in whether it's augmented reality and it uses the hit pose.position, or whether it's on device in Unity and we need to use hit.point. Now this should work on a device and on our in the Unity editor, and that means that we just have to kind of edit this code every time we want to change our game code. Now we might have to do some additional stuff to this and this separately as well. That's always a possibility, but we're moving towards creating something where we can build and test not only on the device but also in the editor. Save us so much time going forwards, and you're going to see how much this is going to save you time. And of course, if you don't have a device at hand, or if you just don't have a device, you can still kind of build stuff. It's never going to be perfect, so that's something to keep in mind. But you can still do quite a lot with this, right? So we've got our camera moving here. It works pretty good. Now there are differences. You can see this is a lot smoother in here compared to on the device. If you remember, it was a bit juttery. So we know there are some differences still from working in Unity Editor and working on the device, but we can still use this to test code out and then build off of that. Now again, it's not perfect because we still need to make some additional stuff. If we run this now, this test floor will be floating in the air. So let's make some additional changes to our code. So let's go in here and let's create a public game object. Game, what's going on here? Game object, an array of game objects, and we're going to call this testing ground. And the reason I'm making it an array, even though we've only got one testing floor, is because I want to be able to be in a position where I could create in the future multiple floors. So I might say, okay, this is for the floor, and this is going to be like an imaginary table that maybe the person has, and an imaginary like bed, and then I could use that to create a bit more of a dynamic testing ground as well for us, right? So let's go back into here. Let's open up this testing ground array. Let's just put one in here because we've only got one testing floor. And then I'm also going to just switch this testing floor to set active equals false, because we don't want that to be appearing when we build it onto our device. It'll just be floating there. We don't want to do that. So we'll switch it off for now. And what we'll do is in the awake function, we'll use our if application dot editor. I'll just paste that in again so I don't make any mistakes. If it's in editor, then we want to switch those testing grounds on. So I'll do a for loop, and I'll do it for, I'll want to go through each one of those positions. So let's just, once we're going through each of those, we want to just set the game object to true, right? Because we're testing in the device. Sorry, we're not testing we're testing in the editor. And if we're testing on the device, then we want to hide it because it's just going to get in the way. We don't need a testing ground. We've got the real ground. We've got the real floor, and the AR core and AR kit will be working anyway. So as you can see, we are scanning the floor and it's working perfectly on the device, just as it was on the editor. So obviously it works for both the editor and the device. There are some differences. Like I said, it's a bit more juttery here, so we can fix this now. We can fix this code inside the editor, and we can test it in the editor and see if there's some differences that might help translate onto the device without having to constantly build. So let's go and do that. Let's go fix this juttering by looking at something called lerping.